Hi everyone, I'm Jackie, and today in this video I will be doing the December 2024 SAT predictions for math. Per usual, let's jump in. Okay, so make sure when you're doing these questions, pause the video, try to solve it, and then look at my resolution, because I think that will be good. Okay, so let's jump in. So first here, in the given equation, Q is a constant. The equation has no solution. What is the value of Q? Okay, so whenever I see no solution and I recognize that there is a linear equation happening, that leads me to believe this is a parallel line, and parallel lines always have the same slope. So a really simple way to solve this would just be to take our original equation, and move the 9x to the other side. And what I'm seeing here, like y equals mx plus b, remember the coefficient in front of x, that refers to the slope. So in here, this would be the slope. And on the right-hand side, this would be the slope. And then I just have to do that 24q is equal to 9. Divide each side by 24. So 9/24 is equal to q. Remember to always put the most simplified version on your answer key. So 3/8. An alternative would be 0.375. So both of these are acceptable, winning answers. Okay, so make sure you know no solutions. This is tested on almost every single SAT exam. I think you might see it on the December SAT. Worth knowing. Okay, continuing our journey. So this one, very similar to the previous one, except it says in the given system of equations, W is a constant. The system has infinitely many solutions. What is the value of W? So again, I recognize there's two linear equations provided. Infinite means that they are the same line, and the same line always has the same slope and same y-intercept. So always for these ones, the first thing you want to do, as mentioned, in my previous videos, that you always want to rearrange in terms of y. So let's do that for the first equation. For example, it'll be 33y is equal to negative 45x minus 159, and then divide everything by 33. So this would be 45x over 33 minus 159 over 33. And to make our life simpler, let's go ahead and simplify it. So here, everything's divisible by 3. So this could simplify to y equals negative 15/11 x. And also here, simplified, dividing by 159 by 3, that's 53. And 33 divided by 3, 11. Okay. So now, same for our second equation. Put everything in terms of y. So 11y equals negative 2wx minus 53, divide everything by 11. So I have negative 2wx over 11 minus 53 over 11. And then just looking at my two equations, I see the y-intercept checks out. It's the same. And therefore, the slope also must be the same. So now I'm just going to take the two equations, or sorry, the two coefficients in front of x, which is slope. Remember from y equals mx plus b, right? Slope. Okay. And then their slopes are the same, so I must set them equal to each other. So negative 215, 2w. And then we can cross multiply. So like negative 165 is equal to negative 22w, and then divide everything by negative 22. And that will give me positive 7.5 for w, and that would be our correct answer. Oh my goodness. Wasn't it amazing? Okay, so next, let's take a look at this. Exponents. Exponents have been coming up on exams, both international and US. Remember, my videos are for across the world. It's global. So let's see. This one here, circling back to exponents, two numbers, a and b, are each greater than 0, and 4 times the square root of a is equal to 9 times the cube root of b. So first, let's translate that into, translate the English into math. So here it would be 4 times the square root of a is equal to 9 times the cubed root of b. Okay, so first things first, if I don't want to, if I want to solve it quickly, it's always simple or easy to convert this into its exponential form. And same, the cubed root of b I can express as b to the 1/3. Also, I can move the 9 over, so I have 4/9 times a to the half is equal to b to the 1/3. Um, and then here, interesting that a is equal to 2/3. So 2/3 times 2/3, that's equal to 4/9. So I can re-express this as 2/3 times 2/3. And then a, it's also 2/3. So I'm going to put that as 2/3 raised to 1/2 is equal to b 1/3. So now bases are all the same. Remember, there's like an invisible exponent attached here. And now I can just do 2/3, 1 plus 1 plus 1/2 is equal to b over 1/3. And this, when I simplify, it's 2/3, 5/2 is equal to b to the 1/3. And now I want to isolate b, like make b stand alone. So what I can do is multiply each side by 3. And just to show, this will become 2/3. I just multiply here, 5 times 3, 15 over 2 is equal to b. And remember, I'm asked for what is the value, what value of x is a of x equal to b. So ax equals b. A is 2/3, so a is 2/3. B is b, and therefore my x value, it's going to be 15 halves, or 7.5, and that's the answer. Wasn't that so amazing? Okay, so let's look at this amazing exponent problem. Okay, so first thing here is I would take these and always convert them, just like I did in the previous ones, into their exponential form. So this is the same as a to the 2/3 to b to the 1/2. And then the other one, there's nothing to do because a to the 2x equals b to the 6. But what I can do is make b stand alone. So I'll multiply each side by 2. In doing so, this just becomes e. And here it would be a to the 4/3. Now I know what b is equal to, so I simply just need to substitute that in for b. So a to the 2x is equal to a to the 4/3 multiplied by 6. And that would be 24 divided by 3, which is 8. And now that the bases are the same, I can take the exponents, set them equal to each other, and x would be equal to 4. Oh my goodness, wasn't that amazing? Alrighty, continuing our journey into some geometry. So this is a classic. I've seen it in Blue Book exams. I've seen it on official SAT exams. And I think it's a concept that could potentially come up in December. If not this exact question, maybe something similar. So keep it in mind. So this one here, in the figure shown, AD is equal to 16, AB is equal to 20. What is the length of BC? Okay, so first things first, I can get what BD is immediately. It's a multiple of 3. So this would just be equal to 12. And the reason I know that quickly without using Pythagorean theorem is this would be like a 4x, 3x, 5x. It's the Pythagorean triplet, the 3, 4, 5. And just to show, like it's 4 times 4, multiples of 4, 3 times 4, 12, and 5 times 4, 20. So since I saw, this was 20, this was 16, I knew almost immediately multiples of 4, 12. Pretty wild, right? Okay, so um next, let's see. So what I would do is just like I can label this A and B for simplicity. And you can always, let's rotate this triangle on its side. So when I rotate the triangle on its side, we would have B here, like the D now would be here. This would be C, this would be A, and hypotenuse would be 16 plus A. My CB value is what I labeled as B, and my AB value, we know it's 20. So you see, I've flipped that onto its side. And now let's look at my triangle here, my pink triangle. Okay, so I can create an equation. I can say 12 squared plus A squared is equal to B squared. And I can also create an equation with this triangle here. I know that B squared plus 20 squared is equal to 16 plus A squared. Amazing. And then now what I can do, oh my goodness, look, I have what B is, so I can substitute this in for here. Let me do that. Do dee dee. So this would be basically 144 plus A squared plus 20 squared, it's 400, is equal to 16. Make sure you expand the brackets. 16 plus A, 16 plus A. So this would be 544 plus A squared is equal to 256 plus 32A plus A squared. Subtract the A's from each side and then subtract 544 minus 256. It is 288 is equal to 32A. Divide by 32, and I get that 9 is equal to A. So that means 9 would be A, but careful, that could be a trap answer. I'm not asked for DC, I'm asked for BC, and just to show, this would be 15. Answer. And the reason I know that, again, so quickly, yes, you can do Pythagorean theorem, but just to show, it is another Pythagorean triplet. 9, 12, 15, they're multiples of 3. The 3, 4, 5 triplet. So this is 4 times 3, and this is 5 times 3. 3, multiples of 3 of the 3, 4, 5. Wasn't that so amazing? Okay, so this one, more geometry. So in the figure shown, O is the center of the circle, and A, B, and C are the points on the circle. If the measure AOB, so that would be the center angle, 72 degrees, what is the measure of ACB? Okay, so if you don't know this theory, pay attention and know it for the exam. So I can see that my center angle, it cuts out from arc AB. And if I look at the angle they're asking for, ACB, it also extends from AB. So the inscribed angle theorem posits that any inscribed angle that is extends from the same arc as the center angle will always be 1/2 of the center angle. And that's all I have to know. So I know that ACB is just going to be 72 divided by 2, which is 36. And that's the answer. Simple. However, you have to know this theory, right, in order to solve it. How amazing. So let's look at this one. Okay, so here it says in the figure, AC is the diameter of the circle with center O, and AC is 10. So whole length 10. Triangle ACB is equilateral. Helpful. So all of the degrees would be 60 degrees. And the length of BP is n times the length of AO. Okay, so this I can solve using my knowledge of 30, 60, 90 triangles. So if this is 60 and this is 30, this would be x root 3, and this would be 2x. So therefore, I know that this is 5 and this is 5. Also the height here, so I'll put it also here. So we can see that the height would be 5 root 3, and this would be like BOA for my triangle. This would be 5, and this is equal to 10. Okay, so I know that. And then from here, I can see from O to P, that would just also be the radius, right? Coming out from the center of the circle. So here it is 5. And if I want to find BP, BP will just be equivalent to BO um, minus PO. And I have what BO is, right? We know BO, it's 5 root 3 minus PO, the radius, which is 5. And another way to see that, they each have 5 in common. I can factor this out. So this would be root 3 minus 1. And it asks me BP, this is BP, is how many is n times the length of AO. I know AO is 5, so 5, this is square root 3 minus 1 times the length of AO. And therefore, our choice would be correct choice C. Oh my goodness, how amazing. All right, next up we have this interesting one. Okay, so it says, in the figure, BC is the diameter of the circle. If the length of BC is equal to 132, okay, so I know this is 132, and the length AB is equal to square root 363. What is the value of BC to BD? Okay, well, I think important to know, and you should know this for the exam, is an important thing about diameters and right angles in circles. So in any circle, if a point lies on the circumference and is connected to the endpoints of the diameter, it's going to form a right angle with the diameter. So this is also known as inscribed angle theorem of the diameter. But anyways, why am I saying this? Because here I have that BC is the diameter, right, of the circle, and angle BAC. So this one here, I'll put it in highlight and then erase, but BAC. So this angle here, um, it's subtended by the diameter. So I know for sure that this angle is going to be 90 degrees. So it's a little bit of theoretical background knowledge on that, but that's why I know for sure that angle BAC is 90 degrees. Alrighty, so then I know that triangle ABC is a right triangle, right? And looking, so we can see, right, that this triangle, it's a right triangle. And then I also have another triangle, right? ADB, so this triangle here. It's 90 degrees. So I have two right triangles happening within this triangle. So I know that ABC, triangle ABC, it's going to be similar to triangle ABD. Similar to triangle ABD. Okay. And why is this? Because I can see first they're both right angle triangles, and also they are sharing a common angle, angle A up here, and it's it's sharing in both triangles. And then I know it applies or checks off the boxes for our angle similarity theorem. So basically, when we have two corresponding angles that are equal to each other, I know that they're going to be similar. Okay, so I know for sure ABC is similar to triangle ABD. And that's very important to solving the problem, which is why I've mentioned it. Okay, actually, this should just have one line, not two. That would be approximate. Okay, so anyways, now I know proportions. I can set them up. So I know that AB, oh, oh my, what happened? Okay, well, sorry, I wanted to like erase that all. So I know that AB is similar to BC, and that's similar to BD, which is similar to AB. So everyone sees that like AB, BC, and then we see BD and also AB. Okay, so now I know that based on similar triangles that the sides are proportional to each other. And then all I need to do is put in the values. And it really is just that simple. Like, let's put it what I had before. So AB, it's square root of, oops, sorry, 363. And BC, I know it's 132. BD, I don't know. That's what I'm solving for. And AB, also it's 300 and square root of 363. And then all I need to do is cross multiply. So I would get like 132 BD is equal to 363. Then just divide each side by 132. Do dee dee dee. Which is just 363 over 132. So I have what BD is, and I'm asked what BC to BD is. So BC, I know it's 132, and BD we just identified as 163 over 132. And let's simplify. So this would really be like 132 multiplied by 132 over 363, which is simplifies to the correct answer, which is 48. And since I feel that I'll probably get questions in the um about the similarity, let me just clarify again that so we see right in the larger triangle. So just to be clear, in triangle ABC, it's similar. My hypotenuse, it's BC. Okay, and that's similar to the hypotenuse in triangle ABD, this one here, which is similar here to AB, which is what I put up in my setup over here. And then likewise, let's look at the legs opposite to the right angles. So in triangle ABC, our larger one, my leg, it's AB, which I'm putting here, right? And um and then my in triangle ABD, I'm referring to this leg. Okay, so that's what I put here. Okay, I just wanted to re-clarify that for similarity. And that's why we can set, the proportion that I did. Hopefully that's clear. And remember the point that I also made at the beginning um, about knowing how to get the right angles. Okay, amazing. Okay, so let's continue our journey. So I've been doing this for the last couple of prediction videos, but it's fundamental and necessary to know three-dimensional figures. So let's take a look at this one. Classic right square pyramids. So a right square pyramid has a height of 11 centimeters. a second right square pyramid has a height of 22 centimeters. The area of the bases of each of the two pyramids is 100 centimeters squared. Which of the following is closest to the difference in surface area of the second pyramid and the surface area of the first pyramid? Okay, so I just drew them out here. But if I want to calculate the surface area, imagine if we unfold this amazing right square pyramid, I would have triangle, 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 and another triangle. They would be equal, but we can see, right, that the area would be the area of the base, aka the square, multiplied by the area of the four triangles. So why don't I find the area then of the triangle? So if I know here that the area of the bases, it's 100 centimeters square, then I know that all these are 10, and that this would just be half of 10, which is 5. And same here, this would also be 5. Then with this, I can calculate the slant height of our pyramid by doing, quickly Pythagorean theorem, 5 squared plus 11 squared equals c squared, which would be, and then same here, we would do 5 squared plus 22 squared, which will be equal to the slant height. So in this case, we have 25 plus 121 equals c squared, which is 146 equals c squared. That is not a perfect square, so I'm just going to leave that as is, that its square root 146 is equal to c. Okay, same here. We would have 20, uh, so this would be 25 plus 484 equals c squared, which is 509 equals c squared. And then I would take the square root, but this is also not a perfect square, so I'm just going to keep that as is. Okay, so that's why probably it says closest to, it's approximation. So I know that the slant height here, it's square root 146, and the slant height here is square root 509. So imagine, so here, if I wanted to calculate the area of the triangle, I have the base, that's 10, slant height here, it's square root 146. So I would just do, right, base times height divided by 2, which it's 5, 146. But then I need to multiply it by 4 because it's for all the four triangles. So this would be 20 root 146, and then plus the surface area, which is 100. Okay, so we have our area for there. And then same with this one, I'm going to do the base of 10 multiplied by its slant height, 509, divided by 2, which we see it's 5, and then also multiply by 4, which is 20 root 509 plus 100. Okay, so I can see that really the difference between the total surface area of the smaller pyramid and this one is essentially the square root in between them. So now I'll just calculate the difference of that. And just to show, whipping out Desmos here. Oh my goodness, look at this. So like 20 square root 509, 20 square root 104, it's approximately 209.55. And looking at the answer choices, that would be closest to option A. So know your right square pyramids. They've been heavily frequented on exams, and then your life will be amazing. Okay, let's continue our journey. Alrighty, now let's look at this one. So the table gives the areas and parameters of two similar rectangles where n is a constant. Okay, so I see rectangle A, I have its area, I have its perimeter. And rectangle B, I have its area and I don't have its perimeter. And then I have to find what the value of n is. So important to recognize in this problem, it says that it's two similar rectangles, which means that the ratio of their areas is going to be the square of the ratio of their side lengths. And that's an important thing to remember. And also, the ratio of their perimeters will be the same as the ratio of their side lengths. So I can just set up like the area of B to area of A, which would be 9,800 over 2450. And oh my goodness, I think this goes in perfectly. Oh my goodness, it's 4. Okay, so that means that the area of rectangle B, like area rectangle B, is 4 times area of rectangle A, which I think makes sense, right? Okay, but so if I want to like relate this ratio of the side length, what I'm going to do, since again, I can do this because the rectangles are similar, then I know that the ratio is the square of the side length. So basically, I would just be like, all right, so k squared, k for square, for, for the side is equal to 4, and then take the square root. So I would have that the side length of 2, which just means the lengths of rectangle B are twice those of rectangle A. And then, now I know that. And now I can calculate. Basically, all I have to do is do 2 times 490, which is 980. And that would be my amazing answer. Okay, so hopefully that makes sense and is amazing. But just basically remember that side lengths in similar rectangles, they will correspond to the different side lengths that they're scaling up by. Perimeters, they always scale by the same ratio as the sides, and areas, they scale by the square of the side ratio. Okay? Remember what I said. Okay, and now moving into, oh my goodness. So here we have a circle in the xy plane has its center at 4, -5, and has the radius of 2, and equation of the circle is x squared minus 8x plus y squared plus 10y plus c equals 0, where c is a constant. What is the value of c? Okay, so whenever you're given this, remember that we know our formula, x minus h squared plus y minus k squared is equal to radius squared. And all I have to do if I want to get what the formula is do x minus 4 squared plus y. And so here, just to show it's -5, so it becomes positive, is equal to the radius 2 squared. And then what I'm going to do is expand the brackets. So again, it's y plus 5. And then this will be x squared minus 8x plus 16 plus y squared plus 10y plus 25, which is equal to 4. And that would be x squared minus 8x plus y squared plus 10y plus 16 plus 25 minus 4, moving the 4 to the other side, equals 0. And you see, I arranged it this way intentionally. So you see x squared, -8x, -8x, y squared, 10y, 10y, and therefore my c value must correspond to 16 plus 25 minus 4, which is 37. Answer. Oh my goodness. Wasn't it amazing? Okay. Oh, a circle has been divided into 3 non-overlapping regions, 1, 2, and 3. The area of region 1 is 4 pi. Region 2, it's 12 pi. And the area of region 3 is 16 pi. And then says, if a point on a circle is selected at random, what is the probability of selecting a point that does not lie in region 2? So first I would sum the total regions, which sums to 32 pi. And then the area not in region 2, that would just be area 1 plus area 3, which is 20 pi. And then we just have to do 20 pi over 32 pi, which simplifies to 5 over 8. So that was a simple one, but I think a good problem to bring up. They incorporate a little bit of geometry mixed with probability. And probability does come up on many exams. All right, continuing. Okay, so also be super familiar with percents. Percents also are in every exam. I've brought them up in like all of my previous exam prediction videos. So keep those in mind. So let's see here. A researcher surveyed undergraduate students, graduate students, and postgraduate students. The number of undergraduate students was okay, so like 74.5% of the number of postdoctoral students surveyed. So like P for postdoctoral students. And the number of graduate students, so graduate students was 24%, the number of undergraduate students surveyed. And then it says there was 3,000, so 3,576 graduate students surveyed. Okay, so I can divide each side by 0.24. Let's do that, which is 14,900 for undergraduate. And now that I have that, now I can substitute this in for my formula here. So 14,900 is equal to 74.5 p, and then divide each side by 74.5. So 200 postdoctoral students, and I'm asked what was the sum of the number of undergraduate students and postdoctoral students. So just 200 plus 14,900, which is the correct answer, 15,100. Okay. Amazing. Uh, okay. So continuing our journey into more percents. Okay, so these also come up on every single exam. Make sure you feel really confident with the compound interest formula, aka like amount equals principal 1 plus or minus the rate raised to the t. Okay, so let's look at this one. It says the equation above can be used to model the population in thousands of a certain city t years after 2000. According to the model, the population is predicted to increase by 0.5% every n months. And then says, what is the value of n? Okay, so first things first, just to show like this part of the equation would be the 1 plus 0.005. So that's where that comes from. The starting value, p, would be the initial value or starting point of the population. And I need to decipher what t over 3 is. So in this case, if I put in 3 for t, what does that look like? This would be 215, 1.005. Oops, sorry. 1 less 0. 5 over 3 over 3. So when I do this, the module becomes 215, 1.005 raised to the 1. But what this is showing that this is what's going to result in an actual increase that causes the population to increase by 0.5%. Does that make sense? However, so that could be a trap answer. That would be in years, but that means that like, so basically every 3 years, the population increases by 0.00, or sorry, was 0.5%. Okay, so if there's 3 years, now we just need to convert it into months, which is there's 12 months in a year, and then 36. And therefore, 36 would be our answer. Wasn't that such a good one? Let's look at another one. So this one, the given function m of t is equal to 10, 1/2 raised to the t. And if you can't see that well, zoom in, but it would be t over 5730. Models the mass of the radioactive isotope carbon-14 in a sample in picograms, t years after the initial measurement. How much time in years does it take for the mass of carbon to decrease to 5 picograms? Okay, so if it's going to decrease to 5 picograms, when would that happen? It's pretty similar to the previous problem. All I would have to do is put in 5730 for t, because in doing so, this would become 10 to the 1/2 raised to the 1, and then 10 times 1/2, it's equal to 5. So how many years does it take for it to become or decrease to 5 picograms? It's 5,730. So amazing, right? Okay, so moving on, let's look at a couple more percent problems. So the reason I want to focus on a couple more of these is that they're super important. They come up on every exam, so make sure you know them. Okay, so a gallery had X artifacts in a collection. When more artifacts were added to this collection, the number of artifacts increased by 149%. What is the result of the number of artifacts in the collection in terms of X? So remember, whenever you're doing an increase, it's like 1 plus k percent. So this would be basically like 1 plus 100 written, 149 written as a percent. It's just 149 divided by 100, which is 1.49. So that would be 1 plus 1.49, which would be 2.49. And then I would multiply that by X. So therefore it's D. However, trap answer would be C. Okay, which would be a 49% increase. Okay. Do. So continuing our journey. Here, oh my goodness, amazing. The segmented bar graph below shows the distribution of students at a university by school in 2022 and 2023. There were 12,000 students enrolled in 2022. If there were 4,000 more students enrolled at the School of Engineering in 2023 than in 2022, which of the following best approximates the increase in the total number of students enrolled at the university from 2022 to 2023? Um, so my first mission, we have to read the graph a little bit, but I can see this is at 30%. Okay, so that means if there was 12,000 students enrolled, um, like basically 12,000 times 0.3 will tell me how many engineering students there are. So that means here there's 3,600 students who are enrolled in the School of Engineering. Okay. Um, and then it says that there were 4,000 students, 4,000 more students enrolled in the School of Engineering in 2023. So this one here would be 3,600 plus 4,000, which is equal to 7,600. So now there's 7,600 students enrolled in the School of Engineering in 2023. And also, I want to see what the increase in the total number of students are. So here I can see this is at 50%. So imagine like 50% of the total students, X, what I'm trying to find, is equal to 7,600. Now I can divide each side by 0.5, and I get that 15,200 would be the total students enrolled in 2023. And now I just need to subtract the difference of 15,200 minus 12,000, which is, oh my goodness, correct answer A, 3,200. Okay, amazing. Look at one more. So this one, W is equal to R squared over R squared plus S squared. And basically, which equation represents S in terms of R and W? So now I want everything in terms of S. So let's see. First I could move like R squared plus S squared over here. Then this would become like WR squared plus WS squared, which is equal to R squared. Now I will move the R's together. So this would be like R squared minus W R squared. Then then I could just divide each side by W. So S squared is equal to R squared minus W squared, WR squared over W. And then final step, just take the square root of S, which that looks exactly like correct answer, choice A. Oh my goodness, how amazing. Okay, so just make sure you feel good with those ones and confident. They come up on almost every SAT exam, so make sure you know them for December. Okay, let's look at a couple more amazing concepts. So this concept, it should look familiar if you've done a couple SAT exams, if you've done Blue Book exams, but these concepts, every single exam. So this one here, it says how many in the given equation, k is a constant, how many distinct real solutions does this equation have? So first I could just subtract 37 from each side, which is 0. Then I can take the square root. The square root of 0 is 0. So I get that x plus k is equal to 0. And therefore, x would be equal to negative k, which I don't have to know what the value of k is. I know it's a constant, but that's going to be my one solution. And therefore, it has exactly one solution. Okay, amazing. Okay, so this one, this is like a shortcut hack. Maybe you know it, maybe you don't. If you don't know it, know for December. So here, if the solution in the given equation, R and S are positive constants, the product of the solutions is KRS, where K is a constant. What is the value of K? Okay, so in this case, there is a shortcut when it is a quadratic equation, aka ax squared plus bx plus c. I know to get the product, I can just do c over a, and this would just be my rs is c, a it's 33, and this is equal to krs. So this would be rs is equal to 33 krs. Divide each side by rs. Rs divided by rs is 1. So 1 is equal to 33k, and therefore 1 over 33 is equal to k, and that's our answer. These have come up randomly on some official exams, so this would be an amazing shortcut to apply in case you have a similar question. Okay, amazing. Well, what about this one? So it says the expression 6x to the fourth power plus 17x squared plus 7 can be written as 3x squared plus a multiplied by 2x squared plus b. And it says where a and b are positive integers. Okay, so first let's deal with this. Hold on. Okay, I just wanted to make more room. So let's make this 6x to the fourth, expand the brackets, right? So this would be plus 3bx squared plus 2ax squared plus ab. And then looking at equation equivalences, I see 6x equals to 6x4. Looking at the x squares in front, so 17 must be equal to 3b plus 2a. And I also know that AB would be equal to 7. Okay, so it does say that these are A and B are positive integers. So 7 is a prime number, therefore it only has two factors. So either A is 1 and B is 7, or A is 7 and B is 1. I don't know quite yet, but I can determine that with this equation. Because let's see, it must be that B is 7, or sorry, it must be that B is 1 and that 2A is equal to 7, because that would be the only condition in which this would equate to 17. Okay, so I know for sure that B is equal to 1 and A is equal to 7 in this case. All right, so I have value of A, but now I need to get C. More complicated. So here, again, we have the same. I would have this is equal to 6x to the fourth plus 17x squared plus 7, and this is equal to 3x squared plus c, and oops, 2x squared plus d. Okay, so expanding the brackets, yes, again, we would have 6x to the fourth, and then here we would have 2 3d x squared plus 2c x squared plus cd. I ran out of space. But anyways, I can see again that 3d plus 2c, you see how I'm using the coefficients in front of the x squares, is equal to 17. And also the 7 here would be equal to c times d. Okay, so this one's a bit more complicated because it tells me that C and D are positive non-integers, meaning it can be maybe a fraction or a decimal. And I have the conditions that multiplied together, it has to equate to 7, right? C times D, and 3D plus 2C equals 17. So we do have two equations. So I can maybe rearrange. Let's do 7. So for example, like 7 over D is equal to C. Then I can put that in for C. So I have 3D plus 2 over 7 over D is equal to 17. And that would be 3D plus 14 over D is equal to 17. Now I will multiply each side by D to cancel out the D here. So I would have 3D squared plus 14 is equal to 17d. And you see I'm getting a nice quadratic equation. So 3d squared minus 17d plus 14 is equal to 0. And this is factorable. So I'm going to solve by factoring. You could alternatively do quadratic equation, but it would be faster to do just this is the same as 3d minus 14, and then d minus 1 equals 0. And then here I would get that my two values. So 3d minus 14 equals 0. 3d equals 14, d equals 14 over 3. And then the other one is just d equals 1. But d can't equal 1 because it has to be a non-integer. So now I know that d is equal to 14 thirds. And then knowing that, so 7 equals, I should have solved for c directly, I suppose, but equals c 14 over 3. And now I can solve for what 3 is, which would just multiply by the reciprocal. Do d, which is 3 halves is equal to c. Okay, so now I have that. And also just to show in case you didn't get how I factored it so quickly, I could go through a whole process of factoring, but an alternative way would just be to whip out your Desmos calculator. I just put x instead of the d, and then I can see where the x-intercepts are, which there's 1 at 1, 0, which was exactly what I solved for, right? D minus 1. And then this 4.66667, that's 14 thirds. So just a quicker way to do it. Okay, and then final step, I am asked for a plus c, which would be 7 plus 14 thirds, which will be equal to um oh, hello, which is going to be 35 thirds, or like 11.66667 repeating. So that was a good equation equivalence problem. How amazing. Alrighty, now let's look at this one. Okay, so this says, which of the following expressions has a factor of x plus 2b, where b is a positive integer constant? If you've been following my videos, I put this in my June predictions video, not this exact problem, because there was a similar one that appeared in October. There's ones that appeared in May. It could be possible that they bring this up again on the December exam. It won't be probably the same problem. Numbers may be changed, but same concept. So make sure you know this. Okay, so it says it has a factor of x plus 2b. And just to see, like, I'm scanning the answer choices, I see all of these values are the same, and the c values are also the same, 14b. So that's going to make my life a lot simpler, I think. So for example, if I have x plus 2b, then I can create um, this must be 3x. Why? Because x times 3x will give me the 3x squared. And then for some constant k that I don't know. And that's going to be equal to, let's just do this for option A for now and see what happens. So this would be 3x squared plus kx plus 6bx plus 2bk. And this is equal to answer choice A, 3x squared plus 7x plus 14b. So we can see 3x squared correlates to 3x squared. Also here, I can factor out the x here. So x, k plus 6b. In this case, this would be equal to 7. And I'm using, again, the coefficients in front. And then I would have 2bk is equal to 14b. Now I can easily solve for what k is, right? Because divide each side by 2b, k equals 7. And then here I have k plus 6b is equal to 7. I know what k is now. It's 7 plus 6b equals 7. 6b equals 0. B equals 0. That doesn't work because it's not giving me b as a positive integer constant. So I must continue the journey. However, my expression, it's going to be the same in each of them. I'll write out one more for b, but it would be the same, that it becomes, I would expand x plus 2b is equal to 3x plus k. It expands to this, and then I could see um, that basically, okay, one more written out, plus kx. Oh no, wait. Okay, so 3x squared plus kx plus 6bx, so exactly the same as above. And this will be equal to, now I'm doing b, 3x squared plus 16x plus 14b. And then again, I can see, right, that the 2bk equals to 14b. That's going to be true in every case. So again, I get that k is equal to 7. And then here it would be that k plus 6b is now equal to 16. And then I would do 7 plus 6b is equal to 16. 6b equals 16 minus 7. which is 9, and then I have that it's 9 divided by 6. So that would be another fraction, 3/2. So it doesn't work. But anyways, like I'm writing it out here for you guys to see the whole process, but I wouldn't keep expanding here. Like I see that it's always going to be that k is equal to 7, and that I'm just setting this expression equal to my b value. So now in C, I would just do that. I'd be like, okay, so k plus 6b, well, and just to even put it simpler, it'd be, okay, let me just write it. K plus 2b is equal to 18. And again, I know my 7 plus 2b is equal to 18, so 2b equals 11. B is equal to 11 divided by 2 does not give me a positive integer constant. Okay. And I'm so sorry. I wrote that incorrectly. I thought something seemed off, but it still won't work. But it was k plus 6b. I put 2b. Very sorry. Um, Good thing I caught it now. Okay, so k plus 6b, it's equal to 18. So, and then we do 7 plus 6b is equal to 18. 6b equals 11. And b 11 over 6, again, does not go in. So it's got to be d, but just to show why d would be our answer. So again, 6 plus 6b is equal to 25. 7 plus 6b is equal to 25. 25 minus 7, that is, oh my goodness, 18, and b is equal to 3. This is the only answer choice that gave me a positive integer constant. The rest gave me either 0 or fractions, or aka non-integers. So that's why it's D. I would know this problem. It's already come up on multiple SAT exams, so maybe it would be in December. Okay, amazing. And I just wanted to do some final questions on trig. Make sure you know trig, you feel comfortable with SOHCAHTOA, and also that like sine of x is equal to cosine 90 minus x, the trig identities, and cosine of x is equal to sine 90 minus x. Okay, but let's look at this problem. So this one says that cosine 4a is equal to sine of 2b, and what is the value of a? Okay, so and then this one, well, first, I know a triangle has 180 degrees, so I would do a plus b plus 143 is equal to 180 degrees. And then I would get that a plus b is equal to 30. Oops. It's equal, yes, I can still do math in my head. 37 degrees. So that would mean that b is equal to 37 minus a. Okay, so that's all good and interesting. And then also just going back to cosine for a is equal to sine of 2b. So if I want to get the value of a, I'm going to put this in, like this would be cosine of 2b, right? So I would be like, all right, so cos for a is equal to cosine of 90 minus 2b. Does everyone agree with my findings? And then that means that the angles inside cosine, they must be equal to each other. Otherwise, this equation couldn't be true. So then I can just set 4a equal to 90 minus 2b. And then I know also what b is equal to, right? 37 minus a. So let's substitute that in here. Do, 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 do. 90 minus 2 times 37 minus a, which would be 4. A is equal to 90. Minus 2 times 3 is 7, 74. And then this would be plus 2a, right? Because negative 2 times negative a. And then I would have 4a is equal to 16 plus 2a. 2a is equal to 16, and a is equal to 8, which looks like that would be the correct answer. Okay, amazing trig problem. But so main takeaway for this problem, know your trig identities, they're important. And okay, so everyone, those are my SAT math predictions for December 2024 exam. I would pay attention to them. Also check out my comment section below or description to check out the previous exam predictions. I say this for every exam, but a lot of my other predictions show up too on the exam. So know everything. And I try not to repeat any questions unless it's a concept that I think for sure will come up. Okay, so like, rate, subscribe if you like this video and you want to keep seeing more. It helps me a lot. And yeah, let me know in the comments what you think or if you have any questions or doubts. And reading and writing will be coming soon. And thank you so much for watching. Bye, guys.